All right, guys, we're starting. This is lesson 7.1. Whoa, I see my hair is everywhere. Y'all are so nice. Okay, y'all are so sweet. It doesn't matter. That's kind of the purpose of it. All right, so we are doing random variables, and this is very, very cool. This is an easy chapter. We're going to be looking at the probability of making an A. The probability of, we're going to be looking at probability distributions, okay, spread out over different outcomes that you could possibly have. So it's very, very simple. It's going to be an easy day. We're going to kind of fly through this. We are going to bring in probability of normal distribution. So we're going to go back to our z-scores and our p-values a little bit and looking at those, which we love, okay? So we're going to be looking at that. There is a video that you're going to be watching called It's Continuous Random Variables versus Discrete Random Variables. So you do kind of need to know the difference between the two, because discrete random variables means that you can actually land on that outcome, okay? So you can land on land on this age group, or you could land on this score, okay? But then there's sometimes a continuous random variable where you can't land on that, but you could fall in the interval of it, okay? And that's a continuous random variable. And it will be obvious and given to you in the problem, but if it's continuous, most likely it's a normal distribution or a uniform distribution, so you'll have to find the area under the curve. If it is a discrete, then you'll be given that probability, okay? So it's a fairly simple concept, okay? All right, so what we're going to be looking at, again, we're going to list what the actual random variable is that we're talking about, and then we are going to list the outcomes, okay? So tell me what you're talking about. What's the data? What's the information we're talking about? What's that random variable? And then what are the possible outcomes? So we're going to list it out. We're going to use a table to do that a lot. And we use capital X or capital Y. We use capital letters to talk about that random variable. And so you'll start to see the process going, okay? All right, so for a discrete random variable, we can make a table. If it's continuous, you can't make a table, but we could draw a picture, okay? So for discrete random variables, we are going to make a table, and for every outcome that is possible, we will list all the outcomes, and then we'll list the corresponding probabilities that go along with the outcomes, okay? But you do have to identify what X is. Let X equal the number of coin tosses. Let X equal my grade on a test. Let X equal, okay? So it could be A, B, C, D, or do y'all do D's here? No, A, B, C, or F, right? So what is the probability that I pass the test? Well, that would be an A or a B or a C, right? And so, so then we would just add up those probabilities, okay? So X would be the grade on a test, and what are the different outcomes? List your outcomes. A, B, C, F. And then underneath it, I would give the probabilities of, maybe the historical probabilities of making an A, B, C, or F on that test. And then we could say, well, what's the probability that I pass? I would just add up A, B, or C. That's pretty easy. So that's what we're doing with discrete random variables. All right, so here we go. A university posts, grades, there you go. A grade distribution for its courses online. Students in statistics, 21% got A's, 43% got B's, 30 C's, 5% D's, and 1% F. Choose a student at random on a 4-point scale, okay? And so we know the scale, the 4.0, 3.0, 2.0, 1.0, or nothing, okay? And it says we can choose a student at random. Let's go ahead and make a table for these values, okay? So come over here. I gave you some empty spots. There might be a table already listed for you on the next slide, but I'm going to go ahead and set it up the way that I feel as though it needs to be set up. So practice on your side of the paper in the blank somewhere. Very first thing you have to do is you have to define your X. Step number 1, always define what your variable is. So what is X going to be here? Statistics grades, okay? So statistics grades that they got for the course. So stats, course, grade. So you've got to say what it is. All right, so define. Your second step, you need to do a table with your outcomes. All right, so we've got X, and we already know what X is, so I can put it right there. and then we have the probability of X occurring. So I know that I have a 0, a 1, a 2, a 3, or a 4, okay? So what, we know that a 4 is an A, like a 4.0, a B, a C, a D, or an F. But I'm using numbers and not letters. I'm not doing categories, okay? I want to be able to put this in my calculator, so we're going to use numerical values. And then all I have to do is list all of my probabilities. What should my probabilities total? 1, okay. So then I just have to put all these in. So I have 0.21, 0.43, 0.30, 0.05, and 0.01. All right, so always make sure that your probabilities total to 1. See if y'all can see that. Sorry, making my little table there. I can't see everything. There we go. All right, so make sure your probabilities total to 1. Now, this right here, you've got to do a table, got to list your outcomes. And then at this point, on part 3, all we're going to do is answer the problem. So you're going to have to answer the problem, but use correct notation. And they haven't even asked us, or we don't know what the question is, but make sure that you use correct notation. That's a big deal. All right, so on this one, it says, find the probability that a student got a B or better, and all we know that that is, we know that this is a B, and we know that this is an A. So the probability, this is how we're going to do it, the probability that a student made an X equals what? X equals 3 or X equals 4. So that is your correct notation. You're not just going to throw an answer down. We have to know how you come about your answer, as easy as it might be. And you can do greater than or equal to 3. I just did 3 or 4, which means the same thing. Okay? All right, so we have 3 or 4. So then all we have to do is total it up. So we have 0.43 plus 0.21, and then you give your solution, which is 0.64. All right, so there's a 64% chance, okay? Now, make sure this is an OR problem. OR means to add, and we know that those are independent of each other, okay? All right, now, this is what a idealized, you can do a probability histogram. We can do one of those values right there, and I did one with you last week. Do y'all remember how we put this data in our calculator? So this is how you're going to put it in. You put this in as L1. You're going to put this in as L2, and then you do one variable stats, and then your X list is L1, and then your frequency is L2. Your frequency is L2. So we can try that real quick. Now, I'm not expecting this to be a normal distribution. And this is discrete, it is not continuous, so I'm not expecting something beautiful or profound to happen, but it is very easy for you to quickly put this data in to your graphing calculator. Oh, I already have 0, 1, 2, 3, and 4. Nice. Whoa, 0.43. And 0.2. All right, so once you have it in, all you have to do is stat, go over one variable stats. Frequency needs to be L2, and then you can calculate. And now this gives you a lot of information right here. This, I've shown you this. This is when we did expected value. On average, I would expect a student to make a 2.78. So they're making somewhere between a B and a C. Okay, so this would be my expected value right there. It does give you the standard deviation right here, and it gives you a list of several different things. But now that I have that information, I can go and graph it by doing the same thing under stat plot. So if I go to second stat plot, go to plot 1, and I am trying to do it's going to be a probability distribution. So I have my data in list 1 and my frequency is L2. So you're going to do a little histogram and then zoom 9. And that looks terrible. Remember when we did that last time? What would I prefer this to count by? Because right now, get rid of my y equals. Right now, this is pretty ugly. And I would like it to count by 0, 1, 2, 3, or 4. I'd like it to count by 1. So how do I change that in my calculator? Do y'all remember? Go to table set. Window. All right, so I want to go 0 through 4, and I want my scale to be 1. And then just press graph, and it'll give you a little bit of a scale there. So I'm going to trace. All right, so 0 through 1, 1 through 2, 2 through 3, 3 through 4, and let's see here. I'm going to go back to my window. I wonder if I did 5. 0, 1, 2, 3, 4. That should be it. Let's trace it and see. So that's 1%, 5%, 3, 30%, 43, and 21. There we go. I did it through 5 because it's doing 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Okay, so I did it through 5 to make sure I had enough bars. All right, so that's the way that you do a probability distribution. That's pretty simple, but you can also calculate doing that one variable stats. All right, let's get back to the notes here. All right. All right, moving on. So here we go. APGAR scores. This is very interesting. And again, we're not going to spend a whole lot of time on this because it is fairly simple. So an APGAR scores, basically, you get scored the first day of your life. Now, how sad is that? So they give you a ranking, and it is 0 through 10. It's based on several different things. It is, but your APGAR score, it says the sum of the 5 different things: muscle tone, breathing, color, all these different things that you could get graded on when you are born. And this is our scale of APGAR scores, okay? So it can be a 0 through 10 ranking. And notice that step 1, define the variable. Step 2, they wrote out their probability distribution. And then at this point, they're going to ask a question. It says, doctors decided that an APGAR score of 7 or higher indicates a healthy child. What is the probability that a randomly selected baby is healthy? This is easy, right? Do you know what you get counted off on? And you don't get essentially correct. You get partially correct or incorrect. You would get partial here if you just added them up and wrote it down. You need to do the correct notation, okay? So make sure that you do your correct notation here. So how are you going to do the correct notation here? Probability that what? X greater than or equal to 7. All right, so that's all you have to do right there. X is greater than, that's it. This goes from essential to partially correct if you do not do the correct notation. I know that's picky. They still want to see it. So at this point, you can do the probability that X equals 7 or X equals 8, and then we can keep going, ... and then come over here and you can list them all out. They want to know where you got your answer from, even on the easy problems. Where did you get the answer from? You saw the girl last night. She put the correct probability for the first one, right, on that student sample. But did she show anything? She showed no work. She showed nothing to support her answer, okay? I just gave y'all a gimme, okay, for those that weren't here. All right, so that's all you have to do. Now, a continuous random variable is basically where you cannot land on a number. There's an infinite number of possibilities between 0 and 1. If I asked you to land on a number between 0 and 1, aren't there infinite numbers between 0 and 1? So that would be considered a continuous random variable, where it'd be hard to actually land on a number because there's an infinite possibilities in between, okay? Continuous, an example, our most classic example of continuous random variable is our normal distribution. On your normal distribution, you can't land on X equals 5. You can do greater than 5, less than 5, between 5 and 7, but you can't land on the number, okay? So on a continuous random variable, if I say the probability of X is greater than 7 or probability of X is greater than or equal to 7, remember those mean the exact same thing because you can't land on a number when it's continuous, okay? So that brings us to our normal distribution, okay? Also our uniform distribution. Again, do y'all remember how to do the uniform distributions here? Do y'all remember how to do these? Okay, length times width. It is a rectangle, length times width. So if they give you what is the probability that X falls between 0.3 and 0.7, you find this distance right there. What is the distance between 0.3 and 0.7? 0.4. All right, so my width and then, or my base, and then my height is 1, so you just do 0.4 times 1, and we get 0.4, and that is the area. So all you're using is your base times height or length times width on uniform distributions. It is a rectangle. That's all you have to do. On this one right here, they use the or, so they say less than or equal to 0.5. You can't actually land on 0.5, so you're just doing less than 0.5. Greater than 0.8 is the same thing as greater than or equal to 0.8, and all you have to do is add them up because of the word or. Easy enough, okay? Uniform distribution, what's your, what formula do you use on these? What formula? Base times height, what formula? Okay, base times height, right? Area is base times height. Base times height, base times height, base times height. I can't tell you how many people look at that and they're like, I don't remember what to do. And then they use a normal distribution on that. All right, so again, a continuous random variable, it takes on all values in an interval. So that is the big thing down here. I said one more time, ignore the difference between a greater than or equal to, or less than or equal to. I'm not going to make you find the area underneath this curve right here. The book puts it in there, I think, to freak you out, okay? This is not going to be the curve that you see. You're going to use a normal distribution curve, okay? Mean, standard deviation, z-scores, and p-values, okay? All right, this is our most classic continuous random variable that you will see. Remember that we use the capital N with the mean and the standard deviation. And once it's standardized, it's on a scale between 0 and 1, which I know that we know that. All right, here we go. Last example of the day. Short notes. Don't y'all love it? All right, so look right here. Now, they won't be so short tomorrow and the next day. But today is just an easy start. All right, so true population probability that a student will report another cheating on, or another student that's cheating is 12%, okay? They tell me that it's normally distributed with a standard deviation of 0.016, okay? Based on a survey of 400 random students, is that enough replication for you guys, 400? Yeah. Okay, it says that we expect on average that it will be around 0.12. That's what it says right there. Now, it says this is continuous because we know that this is a normally distributed curve. And again, if we were to do another set of 400, we might get a different answer, but it might be pretty doggone close because you collected 400. If I just did another set of 20, it might not be 12%, okay? But if you did another set of 400, we would get something that's close, but maybe not exactly the same proportion. Now, it says, what is the probability that the survey results differ? That should not say that should say from the true population more than 2 percentage points, okay? So I'm not really looking at the population here. I'm only looking at 400 people. This is actually called a sample probability distribution. It's called a sampling distribution. But they did tell me that it's normally distributed. So let's just start by looking at our information, okay? We need to identify our variable. We need to identify our x value. In this case, I can't draw a table because it's continuous, so I'm going to draw a picture, okay? All right, let's start with number 1. Let x equal what? What's x going to equal? Okay, let x equal the proportion of students who will what? Report a cheater, right? Snitch on a cheat, right? Report a cheater. Who report cheaters. All right, so we know what that is right now, okay? We know that it's a proportion. We identified the variable. Step number 2, you're going to do a table or a graph. And in this case, I can't do a table, but I can do a graph because it's a continuous random variable. So they did tell me that the mean is 0.12. And of those 400 people, they did tell me that the standard deviation is what? 0.016. So I'm going to do 0.12, 0.016. All right, so that brings me to 0.136. You really don't have to draw all of these in, but you do have to realize what your standard deviation is, okay? I'm going to go ahead and go up one more time over here, and that brings me to 0.152. I'm just going to label 2 down and 2 up, so I have my bearings. 0.104. 0.088. All right, so this is a percentage. It's a proportion, right? And the question down at the bottom of this is, what is the probability that the survey results differ from the true population? Okay, so we don't really know, but we expect that the true population will be close to 12%. What is the probability that it differs by more than 2 percentage points? So I am looking for something that differs more than 2 percentage points. Well, I know that I'm at 12 percentage points right now. I'm at 12%. What would be 2 percentage points away? What would be 2 percentage points away? 14 or 10. Very good. 14 or 10. So I need to know, well, what is the chance that I am more than 2 percentage points off in the positive direction, or you said 10%, which is 2 percentage points off in the other direction. So I need to know these two areas. Now, would you expect these two areas to be the same? Are they the same distance from the middle? So they're the same distance in the tail? So they're going to be exactly the same. You can find both of them. You can go for it. Which one's easier to find? The above or the below? The below usually, because you don't have to do a 1 minus, right? You don't have to do a 1 minus. So, but it doesn't matter whichever one you want to do. But we do need to go ahead and find a z-score, and we need to find a p-value. And then I really can take that p-value and multiply by 2 if I just want to do one tail, okay? So if I want to do the probability of x being, or again, identify what you're doing, x is less than 10. Now you can do the probability that x is less than or equal to 10, okay? All right, so here we go. We're going to do, 0.10. So we're going to do 0.10 minus 0.12, all divided by what? 0.016. All right, so find that probability. All right, what's your z-score? What's your z-score? Negative 1.25. All right, so now look up your p-value. Do you remember how to use the table? All right, negative 1.25. Did you get 0.1056? 0.1056 is what it looks like. So I got 0.1056. And again, we can multiply this times 2. And for upper tail probability. Here we go. And 21.2112. So we have approximately 21.12% that the true population proportion of reporters will differ by more than, I don't know why I'm writing crooked, more than 2 percentage points. All right, there you go. That's easy enough. Don't you feel like you've already done this? Yeah, easy enough. All right, so again, this is a continuous random variable. The only big thing is make sure you identify your variable, do your picture, and then you need to make sure that you have correct notation along the way so that they can follow what you're doing. Okay? 21.12 21.12% probability that the true population proportion of reporters will differ by more than 2 percentage points. So just, again, you can steal the words down here. Don't steal the word fro, steal the other ones. And that's it. Make sure that you draw some sort of conclusion. Easy enough? All right, you have plenty of time to work in class. Bye.